We want to find the volume of the solid obtained by rotating the region bounded by y equals 3x squared, x equals 1, x equals 3, and y equals 0 about the x-axis. And we'll do this using the disk method. So first, here's the graph of y equals 3x squared. Here's the graph of x equals 1. Here's the graph of x equals 3. And y equals 0 would be the x-axis. So the bounded region would be this region here. If we rotate this region about the x-axis, notice how it would form this solid here, and our goal is to find the volume of this solid. We'll do this using the formula v equals pi times the integral of f of x squared from a to b. Before we apply this though, let's look at where this comes from. If we were to sketch a small thin rectangle of this bounded region like this, where this would be delta x, and the height would be f of x, or the function value. If we rotate this about the x-axis, notice how this would be a very thin right circular cylinder that would look something like this. We know the volume of a right circular cylinder is equal to pi r squared h, where in this case, this distance here would be r the radius, and this distance here would be the height. But notice how we can see this formula in the integral we're using to find the volume. Here's the pi. R squared, the radius squared, is actually going to be the same as the function value squared. And then the height of the right circular cylinder, h, is actually dx, or delta x. So to visualize this, if we rotate a region about the x-axis, it might look something like this. To approximate this volume, we could use right circular cylinders, as we see here, but notice as the number of right circular cylinders increases and approaches infinity, the volume of the disks, or right circular cylinders, would approach the volume of the solid. So as the number of disks approach infinity, this forms our integral that we're using to find the volume. So going back to our example, let's go ahead and set this up. We're going to have the volume is equal to pi times the integral of f of x squared, which would be 3x to the second squared, from 1 to 3. So this is going to be pi times the integral of, this would be 9x to the fourth, from 1 to 3. Let's go and evaluate this on the next slide. The antiderivative of 9x to the fourth would be 9 times x to the fifth divided by 5. Let's go ahead and factor out the 9/5. This would give us 9 pi divided by 5. And now we'll evaluate x to the fifth at 3, and then 1, and then find the difference. So when x is 3, we have 3 to the fifth, and when x is 1, we have 1 to the fifth. Well, 3 to the fifth is 243, 1 to the fifth is 1, so this gives us 242. 9 pi over 5 times 242 is equal to 2,178 pi divided by 5, which would be the volume of the solid. So this would be cubic units. Let's also get a decimal approximation though. This will be approximately 1,368.478 cubic units. For our homework though, we should enter the exact value unless we're told to round. So again, this is the volume of this solid here. I hope you found this helpful.